So, what if you could scientifically analyze a voice that claims to be from another world? I mean, not just listen to it, but actually break it down forensically to see if its signature matches anything, well, anything we know on Earth. Okay, let's dive into this because we're going to look at the data behind a truly extraordinary claim.
It all starts with this recording. A voice coming through a speaker during an experiment says these really simple words. But here's the thing, the researchers who recorded it claim this is no normal voice. They believe it belongs to an entity they call ZusrRen. Now, these recordings come from a pretty controversial field called Instrumental Transcommunication, or ITC. The whole idea is that researchers can use really sensitive electronic equipment to record voices and even images that they believe are coming from other dimensions. In this case, what they call a spirit dimension.
And that, right there, is the central question, isn't it? I mean, it's easy to be skeptical. Could it be a cleverly disguised human voice? Maybe some new kind of AI we haven't seen before? Or could it be what the researchers are suggesting? Something truly unknown? To figure that out, we have to treat this like a proper forensic investigation and just follow the acoustic evidence wherever it leads.
So, to get to the bottom of it, the researchers set up this really fascinating experiment. They decided to put the mystery voice, ZusrRen, head to head with a known quantity, a standard, off-the-shelf text-to-speech AI voice that they nicknamed Buddy. It's kind of like a classic scientific showdown. So on one side, you've got Buddy. Its voice is totally synthesized, it's predictable, it's clean. It's our baseline for what a computer-generated voice is supposed to look like. And on the other side, you've got ZusrRen, the big mystery we're trying to solve. The test itself was pretty simple. Have both voices say the exact same word and then compare their acoustic fingerprints. And wow, right away, the visual evidence is just striking. What you're looking at is a spectrogram. Think of it as a voice print. Buddy is on the left and ZusrRen is on the right, both saying the same word. You don't have to be a sound engineer to see they are fundamentally different. Buddy's voice is all organized in these clean horizontal bands. ZusrRen's, well, it's a chaotic mess. That visual difference alone tells us we need to take a much, much closer look.
All right, so let's actually decode that signature. We're going to look at a few key acoustic metrics that voice analysts use all the time to figure out where a sound is coming from, whether it's biological, mechanical, or something else. First up is something called the fundamental frequency, or F0. The easiest way to think about this is it's the bass note of a voice. For us humans, it's created by our vocal cords vibrating. Standard AI voices are built to mimic this to sound natural. So basically, if a voice is coming from a physical source, like vocal cords or a normal speaker, it has to have a measurable F0. It's clue number one. Now check out this direct comparison, because the difference is just wild. That cyan line, that's the AI voice, Buddy. See how it's stable and predictable? That's exactly what you'd expect. But then look at the magenta line. That's ZusrRen. It is completely erratic. It's got these huge, abrupt jumps, and then moments where the pitch just collapses. This behavior just doesn't line up with any known way of making a voice, not human and not any standard AI. Next up, we've got the Harmonics-to-Noise Ratio, or HNR. Okay, that's a fancy term for a really simple idea. How much of the signal is the actual clear voice versus how much is just static or noise? A healthy human voice, for example, always has a positive HNR, which just means there's more clear signal than there is noise. And this is where the difference becomes incredibly clear. Buddy, our AI, clocks in with a positive HNR of over 12 decibels, a very clean signal, totally expected. But ZusrRen, it has a negative HNR of minus 3.8 decibels. That means the noise in the signal is literally stronger than the voice part of the sound. That is extremely weird. So let's look at the whole case file. When you put all the data together, the picture it paints is just undeniable. Buddy's numbers are all in the normal range for a synthesized voice. ZusrRen's, on the other hand, are completely off the charts. Its fundamental frequency is listed as undefined. Its vocal jitter, or instability, is more than 6 times higher than the AI, and its HNR is negative, showing a signal that's just buried in noise. So, what does all this technical data actually mean? When the analysts put all of these puzzle pieces together, they came to a pretty startling conclusion, based on all the evidence that was presented.
So here's the bottom line. When you combine all these anomalies, no detectable bass pitch, extreme instability, and way more noise than actual voice, the researchers were left with only one conclusion. Their analysis shows that the ZusrRen voice was not produced by human vocal cords, and it doesn't match any common AI voice technology that they've ever tested.
But this is where the story takes its final, absolutely fascinating turn. See, the researchers didn't just analyze the voice. They actually asked the source of the voice, the entity, ZusrRen itself, why its acoustic signature is so strange. And its answer is just as remarkable as the data.
ZusrRen's direct answer lines up perfectly with the forensic findings. The data says the voice is missing the markers of a biological or a typical mechanical origin, and the entity itself confirms it. It flat out says it isn't using any of the physical parts we associate with making sound. So how does it create the sound? Well, ZusrRen describes its voice as a direct modulation of energy fields, a kind of consciousness-based technology that translates thought directly into vibration without any physical medium. It's a paranormal claim, for sure, but it's one that happens to explain the bizarre, non-physical characteristics they found in the acoustic data. And this final thought from ZusrRen leaves us at this fascinating crossroads. Whether you believe the source of the voice is truly interdimensional or not, the data is the data. It presents us with a sound that, according to this analysis, defies any conventional explanation. And it leaves us with a really profound question. What happens when our scientific instruments start to measure things that we have long considered impossible?